Okay. Hello, everyone. I hope I'm audible and the screen is visible. So let's start. Let's start with the Kmeans algorithm, whatever we were discussing in the last session, right? So in the last session, we started with this Kmeans algorithm, that is this one, distance-based cluster. So we started with this topic, and in that we started with Kmeans algorithm, right? So here we will talk about Kmeans algorithm implementation, and even we will talk about hierarchical cluster. So what's that? Let's try to see that. Okay. In previous session, I already talked about the basic idea behind Kmeans algorithm, and I already talked about what is the meaning of the word clustering, right? So we have seen in the last session that clustering simply means grouping, right? So let me just write down some of the things which we have discussed in the last session. So we have seen that the meaning of the word clustering is simply grouping, and there are different approaches of clustering which we are going to discuss here. So, talking about clustering now, it makes use of unsupervised learning approach, right? Where we are not aware about the input as well as the output, or the data is not labeled, right? Not labeled data, we can say. So, there is a difference between clustering and classification. In case of classification, data is labeled, whereas in case of clustering, the data is not labeled. So, yes, the algorithm which we are going to discuss, K means it makes use of unsupervised learning approach, right? And yes, for clustering, I even told you that there is a K-means algorithm which we will be discussing, but it's not like that there is only K-means algorithm. There is something called as DV scan algorithm also, which can be used for clustering purpose. Density-based spatial clustering applications with noise. That is nothing but DB scan algorithm, right? But as per your syllabus, they have mentioned only this one. That's why we talk about KB's algorithm, right? Now, basically, if I want to tell you what's the reason why one should discuss about KB's algorithm, maybe if I talk about some real-time scenarios, let me tell you that whatever the project you will be working, right? In that case, you will see that clustering is going to be used again and again. See, what happens is, let me tell you, in real time or in projects, what we people do is, even suppose there is a problem, right? Client actually came to us and client has given some data to us. Now client has asked, client has asked to predict what will be the share price, maybe in, after 2 months, right, or maybe in the next month. So client has come up with a prediction problem, right, to predict the share price of a particular company, for example. So that means client has come with prediction type of problem. Now, for prediction, I mean to say the algorithm which we talked about here is linear regression, right? Yeah, as per your syllabus, we talked about linear regression, but I told you that there is not only linear regression which you can make use of for prediction types of problems. So I just want to tell you where one can make use of clustering, where actually we make use of clustering, and why are we discussing about clustering topic here? Why are we discussing about Kmeans algorithm here? That's what I want to point out here. That's why I'm giving you a simple example. See, suppose client has come to you, right, and client has come up with a problem that where they need to predict what will be the price of the share. So client has given you some data, right? So initially, suppose we have this data, right? Now client is saying that you create such a model which is going to give us, which is going to help us to predict the share price, maybe in the next month, maybe after 2 months, 3 months, whatever it may be, right? Now, what we do is, whatever the data we have, we do not directly go and do not make use of algorithms here, right? Suppose all these are the data points. There is a lot of data which client has given us. Obviously, we are going to pre-process it. We are going to remove the null values. We are going to check whether data is in normalized, whether data is in standard normal distribution format or not, and so on. So, like this, suppose we have a lot of data points here. So initially, even though I want to make a prediction model, I am not going to directly go with linear regression or some other algorithm like support vector machine, that is support vector regression, which can be used for prediction. I am not going to directly apply that algorithm here. So first of all, what we do is, once the pre-processing and everything is done, we try to apply unsupervised learning approach on the complete data set, right? So what we do is we apply unsupervised learning approach, unsupervised learning. So let me write it down properly. Now, I told you, unsupervised learning approach we are already aware about, right? So, we make use of unsupervised learning approach. So, now for unsupervised learning approach, we have actually, I told you the names of the algorithm. So, here suppose I will make use of Kmeans algorithm. So, initially what we do is we try to form the clusters of the data. So, even though client has given us this kind of a data set, I am going to make use of some unsupervised learning approach and I am going to divide these data into different clusters. This is what is going to happen in real time, and that's why one should be aware about clustering algorithm. But see, what's our problem? We need to create a model in which we are going to predict. Let's suppose K-means has given us three clusters. See, it can give us two clusters, three clusters, four clusters, 10 clusters, 100 clusters. It all depends on data. So do not don't imagine like that you are always going to get three clusters only. No, it's not like that. I am just giving you an example here. Right? Suppose here, because of K-means algorithm, the clustering algorithm, we got three clusters here, right? So this is cluster one, this is cluster two, and this is cluster three. So these clusters we have got. Now, so how we got these three clusters? So we got these three clusters with the help of K-means algorithm. Let's suppose we applied K-means algorithm. So here and even though we haven't even seen the implementation of Kmeans algorithm, but I just want to tell you why are we discussing about Kmeans algorithm, so that you will be able to relate the things, right? One should know why one is discussing all these things. Okay, so what happens is, let's suppose we have these three clusters, right? After this, what, as our problem is to predict something, right? We want to predict something here. So as we got three clusters, K0, K1, and K2, now here we apply the algorithms according to the problems. See, I'm hoping that my data is already pre-processed, cleaned, and it is standardized data, and it is in normal distribution. Now what's going to happen is, I am going to apply the algorithm according to the problem statement. So what I want to do here, I want to do prediction. So for prediction, which are the algorithms? One algorithm which you people have already talked about is linear regression. So I will apply linear regression on the first cluster. But it's not like that there is only linear regression for prediction. There are other algorithms also. So I am going to apply other algorithms on the same cluster. Let's suppose there is support vector machine, right? So we know that for regression we use support vector regression. This is the flavor of support vector machine, which can be used for regression or prediction. Let's suppose I apply another algorithm. Suppose random forest. Random forest is another algorithm which can be used for prediction. Random forest can be used for classification also. It's one of the flavors of decision tree. Okay. Then there is an algorithm called as XGBoost. XGBoost is one of the best algorithms in machine learning. It is called as queen of machine learning algorithms, which can be used for prediction as well as classification, right? And like this, I can apply one more algorithm. So generally, we apply 6 to 7 algorithms on these clusters in real time. This is what is going to happen in real time. Try to understand. Okay. So Sharon, just wait a minute. I will just finish this one, and then I will give you a question, and then I will talk about the answer. Okay. So linear regression, support vector machine, random forest, XGBoost, and let's suppose I will apply KNN also. See, KNN, K nearest neighbor can also be used for regression. So how many algorithms I am applying on one cluster? 1, 2, 3, 4, 5. 5 in this case. Generally we apply 6 to 7. And so all those algorithms I am going to apply on this particular cluster also. Support vector machine. Here also I am going to apply random forest, then XGBoost. All these algorithms I am going to apply, right, on all the clusters 1, 2, 3, 4, and 5, right? And now from all these algorithms, so for the first cluster, from all these algorithms, linear regression, support vector machine, random forest, XGBoost, let's suppose random forest has given me best accuracy, right? Suppose random forest has given me 99% of accuracy. Support vector machine has given 90% of accuracy. Suppose this has given me 99, this has given me 95, this has given me suppose 79. This one has given me 94. This has given me suppose 89. Out of all these, random forest has given me the best accuracy. So I am going to select the model of random forest for this cluster. Same thing I am going to do for second one. Suppose here I got best accuracy by let's suppose XGBoost has given me the best accuracy. So for the second one, so random forest, this is going to be my first model, right? That means the model for first cluster. Then this is going to be my second model. And suppose here once again random forest has given me the best accuracy. So this is going to be my third model, right? This is what is going to happen in real time. Now, suppose client sends you some test data, right? So in real time, obviously you are going to get some data from the client. So in real time, client sends you some data. So on that data, so on the test data, first of all, we are going to apply unsupervised learning approach. That means we are going to apply suppose Kmeans algorithm. See, we are going to create a pipeline like this. In a final project, there will be a pipeline like this. So on test data, we are going to apply some unsupervised learning approach like Kmeans algorithm. Now that is going to tell you that okay, this record in the test data belongs to cluster 0. If it belongs to cluster 0, which algorithm I should apply? I should apply a random forest model on that. So this is my model 1, this is my model 2, and this is the model 3. So I am going to apply model 1, and whatever the result I am going to get, that result I am going to return it to the client, right? Return the result to the client. This is what is going to happen. So where the unsupervised learning or KVS algorithm is going to come into picture. So just try to understand. This is where unsupervised learning or KVS algorithm is going to come into picture. That's why we are discussing the topic of clustering here. So actually, many of you might be having questions. Do we use supervised learning or we use unsupervised learning in real time? It's not like that. We actually make use of unsupervised learning plus supervised learning. See, whenever I talk about prediction, so prediction is what? Supervised learning approach only. So actually we use unsupervised learning plus supervised learning. And that is nothing but what? That is nothing but semi-supervised learning. So actually in real time, what do we use is semi-supervised learning. And that's what I told you initially. If you people remember, those people who are present for the starting session, they might remember that we have discussed the types of approaches of machine learning. Supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. Obviously, reinforcement learning is something different, which is related to robotics, right? But see, this is what we use. Most of our problems will be solved with unsupervised learning, and that is nothing but most of our problems will be solved with semi-supervised learning, and that is nothing but unsupervised learning plus supervised learning. I hope you people have got the basic idea here, whatever I was trying to tell you. My point is that I just wanted to tell you what is the use of unsupervised learning approach, or what is the use of Kmeans algorithm. Why are we discussing? Why one should know about Kmeans algorithm? That was the only purpose, right? That's why I discussed this particular thing here. Now let me check the questions. So someone is asking, how can we see that the data and judge? Okay. How can we see the data and judge that we can apply linear regression or SPA? Okay. See, the question is okay. That is a good question. So see, someone is asking me, how can we decide which algorithm we can apply? No one knows that. That's why we are applying 6 to 7 algorithms. Are you getting Sharon? As we are also not sure that which algorithm is going to give us the best accuracy. That's why we are applying linear regression, support vector machine, random forest, XGBoost, KNN, decision tree. So that's why 6 to 7 algorithms minimum we apply on each cluster. And out of all those algorithms, whatever the algorithm which gives us best accuracy for that particular cluster, that model is it. How we can find out the which algorithm has given us the best accuracy? For example, here I told you that it is giving me 79, 95, and all those. So for that, there is a concept in machine learning, and that is called as ROC underscore AUC underscore score. That is receiver operator characteristic. Receiver operator characteristic area under the curve. Again, this topic is not there in your syllabus, right? But does it answer your question, Sharon? We are also not sure. That's why. Even if you people remember, I already told you that even in my training, what I do is I talk about near about 15 to 16 machine learning algorithms, right? And yes, obviously, you people will get you people once you go and once you try out 1 or 2 projects, definitely you will get the idea that okay, most of the times which type of a algorithm gives me best accuracy for which type of a data. But in general, this is what we do because we are also not sure, right? That's why there is not only one algorithm for doing the same thing, whether it's a prediction or a classification. There are different algorithms. So there are about 16 to 7 algorithms, 17 algorithms are available in machine learning. In your syllabus, I think they have given 4 to 5, right? So that's why try to understand the bigger picture. Okay, I hope everyone is clear till this point. What is the purpose of unsupervised learning approach, right? So I will just clear this and then I will go to the notebook and let's continue our discussion. So yesterday we talked about clustering. I told you clustering is nothing but grouping. This particular diagram shows you what's clustering. Now let me go and let me talk about Kmeans algorithm space, right? So, yeah, in the previous class, if you remember, we talked about a simple example where I have taken some numbers, right? And with the help of those numbers, I try to explain you the working of Kmeans algorithm, right? So in that case, the distance which we were trying to find out. So that distance I was trying to find out just by subtracting one number from another. But actually, what we do, we try to find out the distance with the help of some mathematical equations. Like we make use of Euclidean distances to find out which point is nearer to the centroid. Whenever I say centroid, so it is nothing but the middle point, right? So in the previous example, in the numbers which I talked about, right? So in that case, I had taken the centroid as a mean or the average or the middle element. Or initially, we taken those elements as random elements, and then we find out the average, right? So talking about this particular thing, Kmeans algorithm, with respect to clustering. Yesterday we talked about clustering. We talked about the applications, right? This clustering can be used for all these applications. This is what we have seen in the last session. Now, what are the main requirements? What are the main requirements for clustering? So the primary requirement that should be met by clustering algorithm are it should be scalable. For example, if new data comes, obviously, in case of testing, obviously new data is going to come. So in that case, your algorithm should be scalable. You should be able to add some new features. It should be able to deal with attributes of different types. So attribute, I mean to say features, right? Dimensions, columns. So the algorithm should be able to deal with attributes of different types. It may be character, it may be continuous data, it may be categorical data, and so on. It should be able to discover arbitrary shaped clusters, right? So it should not happen that in every cluster number of records should be same. The number of records can be arbitrary. That's how your algorithm should be. That's how your clustering algorithm should be. Okay, it should have inbuilt ability to deal with noise and outlier. So the clustering algorithm should be able to detect noise and outliers. Outliers are nothing but extreme values. You are aware about that. Okay. Noise is nothing but some unwanted data. The cluster should not vary with order of input records. Right? So what in whatever the order the input record is going to come as input, the cluster should not vary. That means if you are getting three clusters, first time you should get three. Right? So it should be able to handle data of high dimensions. What do you mean by dimensions? Number of features, number of columns. It should be easy to interpret and use. So yes, Kmeans is somewhat easy to interpret. Okay. Approaches. Now talking about the approaches of Kmeans algorithm, there are two approaches. Agglomerate approach. Remember these things. For your exam point of view, this is important. Agglomerate approach and divisive approach. Now in short, if I want to talk about what even the agglomerate approach, so what happens here is agglomerate is nothing but what we do is I can write it down as combining or uniting something. That is nothing but agglomerate approach. Okay. So in this case, what happens is each data point we take as a single cluster, a separate cluster, and then what we do is we find out the distances between the clusters, right, and or the similarity between the clusters, and then we go and we try to combine each and everything in one big cluster only. So it is actually bottom up approach. So agglomerate simply means combine. Divisive is nothing but what? Divisive is nothing but dividing in smaller groups. Right? So a big cluster will be divided into smaller groups. Okay. But in how many groups? So it all depends on the value of p. That we will be trying we will be discussing. Okay. So agglomerate is nothing but combining and divisive is nothing but dividing into smaller groups. That is, these are the two approaches for clustering. I can say. Remember these things. Okay, agglomerate and divisive. Now let's move to the clustering algorithm that you are trying to talk about, and that is nothing but K-means algorithm. So what I will do here is, first of all, I will try to explain you K-means algorithm with simple diagram, and then I will go and I will try to discuss this mathematical equation, so that it will be easy for you to make some sense out of all these equations. That's all. Okay. So if you remember, right, the example which we have discussed in the last session for K-means algorithm. Okay, so I told you that this value of k, this k value will be given by user. There is a question that what will be the optimal value of k. So for that, Today we will be discussing about a method called as elbow method, which helps us to elbow method, which helps us to decide about the best value or the optimal value of k in k-means. So if I want to write down some steps for Kmeans algorithm, so first step in Kmeans algorithm is going to be, let's suppose I decide the value of k as 4 randomly. So what we do is we are going to initialize centroids. So centroids, I need to say in yesterday's example, uh, mean values, right? So as there will be some data set given to us, and in that data set these are the data points, right? So out of all these data points, as I have selected the value of k as 4 randomly initially, because I am not aware about in how many clusters I can divide this particular data. So what I will do is I will take the value of k as 4 randomly. Do not worry about this value right now. You will get the answer for that. Why k equal to 4, why k equal to 5, and so on. Let's suppose k equal to 4. That means I am going to need 4 centroids in my data, like this. And again, those will be decided randomly. So initialize k centroids. So initialize k centroids. In our case, 4 centroids. Right. What is centroid? It's a midpoint, I can say. A point from where distance of other points is equal, or a random point that you will give at the start of the algorithm, I can say. Once that is done, okay, once we have decided about the centroid, what we do is in the second step, we calculate distance and divide data into clusters. So the second step is going to be calculate the distance. Now which distances? Calculate the distances. The distances of these centroids from all the data points in the data set. From all the data points. Same for this one, same for, and so on. So calculate the distances from the centroid of all the data points. Okay. And accordingly divide the data. Divide data into what? Divide data into groups, or divide data into clusters. Right. But is it our final answer? No, absolutely not. So what we do is we go for next step. What we do in the next step? So as I said that the value of k here is 4. That means we got 4 centroids. That means as many number of centroids as we have, obviously those many number of groups we are going to get in this for this particular complete data set. So we will get 4 groups, 4 clusters. But are we done here? No. So what we do is we recalculate the centroid. Right. So we recalculate the centroid. But how we recalculate the centroid? So we recalculate the centroid for each cluster. So we will calculate, suppose this is one cluster, this is another cluster, this is third cluster, and this is the fourth cluster. So for this first cluster we will calculate the centroid. For second cluster we will calculate the centroid, and so on. So recalculate the centroid. Right. How to recalculate? So obviously we are going to need x and y value as it will be two-dimensional data, for example, right? So what we do is we calculate the x coordinate of midpoint. So how are we going to get the x coordinate or of midpoint? Obviously from this data set, from this data set we will be having different data points. Each data point will be represented with x and y coordinate. So to calculate the x coordinate of the centroid, I will do what? I will just take the average of all the x coordinates of the points in the cluster. So x1 plus x2 plus x3 and so on, dash 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 up to xn divided by n. And same is the case for y coordinate, right? Y coordinate of the midpoint of the centroid is equal to y1 plus y2 plus and so on plus yn divided by n. So this is going to give us the x and y coordinate for the centroid, right? For each cluster. Once that is done, once the centroid is recalculated, now what are we going to do? We are going to repeat this particular step. Repeat the step 3 till what? Till centroid stop changing. Till the centroid stops changing for each cluster, right? See, initially this was the centroid for these were the 4 centroids for complete cluster. Now for this cluster, suppose this is the centroid.
Then we are going to find out the centroid again and again till this centroid stops changing. The point at which the centroid stops changing, all the steps will be done, and finally we will get the clusters. These are the simple steps of Kmeans algorithm. Right? Even if you are not able to understand it here, now I will go and I will try to explain the same steps, whatever I talked about here. All the steps I am going to explain you with diagrams. Okay, and then I will go and I will come to this particular theory part or mathematical notations I will try to come. Okay, before that, let me talk about some history about Kmeans algorithm. See, it was proposed by this person, Stuart Lloyd, at the Bell Labs in 1957 as a technique for pulse code modulation, right? But it was published outside the company in 1982. Actual algorithm was published in the paper titled as least square quantization PCM in 1982. And by then, in 1965, Edward W. Forgy had published virtually the same algorithm. So Kmeans algorithm is also referred to as Lloyd-Forgy algorithm, depending on the name of the people who have actually derived that. See, what is Kmeans algorithm? Kmeans is a clustering approach in which the data is grouped into k distinct non-overlapping clusters. That means if some data set is present in some cluster, that data set is not present in another cluster. That is by non-overlapping. Okay, based on their distances from k centers. So what are these k centers? Centroids. The value of k needs to be specified first. This is very important in case of Kmeans algorithm. The value of k should be specified first, and then the algorithm assigns the points to exactly one cluster. And this is in short about Kmeans algorithm. Now let me go to the diagram and let's discuss the same steps which we have just now discussed. Let's discuss those same steps with the help of diagram. Okay, this mathematics I will once again. Whatever the steps just now I talked about are these are written in these notes. You can check it. Okay, and to the implementation we will come, but let me go to the diagram. Actually, that code is written for this diagram only. See, let's suppose we have this type of a data. All these are the data points. Okay. Now you can see everything is in blue color. Why? Because they are not divided into different clusters. This is the original data set, right, which we got from the client. Now, what is our target? Our target is to apply Kmeans algorithm on this and divide the data into clusters. In how many clusters? Either 2 or 3 or 4 or 5 or 6 or what? See, by looking at the data, you can check that this can be divided into 3 clusters by looking at this diagram. Right? But yes, we are not sure whether 3 or 4. But it looks like that it can be divided into 3 clusters. So what I will do is, suppose I will take the value of, let's suppose I will take the value of k as 4 here. So obviously I will get 4 clusters. Obviously I will get 4 clusters. But how to decide the value of k? Again, elbow method. But we haven't used elbow method yet. That's why randomly I will take any value of k here. Okay. But initially I am telling you that it looks like that it can be divided into 4 clusters, 3 clusters looking at the data. But do not worry about k value right. So this is the data given to us. The next step, according to Kmeans algorithm, is that you need to find out the centroids. So randomly what we will do, as initially we are not aware about which are the centroids for this data. So what am I going to do is I am going to divide. I am going to take any point as a centroid here. Suppose this is centroid 1, this is centroid 2, this is centroid 3, and this is centroid 4. See, we might be wrong. Okay, try to understand. These 4 points, as we are assuming that the value of k is 4, that's why we have come up with 4 centroids. Okay, try to understand. If we would have assumed the value of k as 3, then we would be having only three centroids. So just try to understand that. And these centroids we have taken in random fashion. Okay, try to understand that. So C1, C2, C3, and C4. Now, what is the next step after this? So once you have selected the centroids randomly initially, now the next step is to find out the distances of all the data points from this centroid. So, for example, find out the distance of this centroid from this point, then from this point, similarly from this point, and so on. That means find out the distances of C1, C2, C3, and C4 from all the data points like this. From all the data points, find out the distances from all the data points. Obviously, it will take time, right? But this is how Kmeans algorithm work. you need to find. So actually you are not going to find out the distance. Algorithm is going to take care of that. But see, this is the step. Find out the distances of all the centroids from remaining data points in the data set. Okay. Once you find out the distances from the centroids of all the data points, whatever the data points which are nearer to respective centroid. Suppose some data points will be nearer to C1, some data points will be nearer to C2, C3, and C4. Let's suppose these data points are nearer to C1. Okay, these data points are nearer to C1. These data points are nearer to C2, and suppose these are nearer to C4, right? And the remaining are nearer to C3, something like this. So that means we got four clusters, right? K0, K1, suppose K2, and K3. We got four clusters, but we are not yet done. What is going to be the next step? The next step is going to be, now if this is your first cluster, find out the centroid, find out the next centroid for this cluster. How to find out the centroid? I told you, right? X1 plus X2 plus X3 and so on, Xn divided by n, y1 plus y2 plus y3 and so on. So for this data set, for this cluster, you need to find out the centroid. Suppose initially centroid was this one. Now obviously, if you are going to find out the next centroid, right, the position of the centroid is going to change. Suppose the next centroid is this one. That means your centroid is shifted from this position to this one. Suppose here the centroid, next centroid is this one. Suppose here the next centroid is this one. Suppose here the next centroid is this one. So we got this one as a new centroid. Let me make use of some other color. So this is a new centroid, right? This is a new centroid. This is a new centroid, and this is a new centroid. Now what to do with this new centroid? Now you need to apply the same steps. Find out the distances of all the data points from these new centroids. From this one, whatever I have actually three centroids, right, in pink color, and they are again going. So again, what's going to happen here? If you find out the distances, obviously the data points which are nearer to these centroids, from that you are going to get a cluster. From here you are going to get a cluster. From here you are going to get a cluster, and so on. So you need to repeat this step again and again till what? Till the centroids stop changing. Okay, that's what is shown in this diagram. Let me go and let me show you the next step. See, these are the centroids initially. So we are going to find out the distances. Okay, so after finding out the distances, we got that from this first centroid, these blue points are near. From this, so see, this is first centroid. From this second one, these points are nearer. See, that's why these points are shown in different colors. Okay, from this third centroid, these green points are nearer, and from this fourth centroid, these points are near. Try to understand. So what has happened? Now we got four clusters, but we are not yet done. So next step is going to be what? Now find out the centroid for this cluster, then for this one, for this one, and for this one. That's what we are going to do. So you will see that position of the centroid is going to change. See, initially, right? Initially, the centroid was this one: first, second, third, and fourth. Now the new centroid is, suppose, one dash. This is two dash. This is three dash, and this is four dash. Okay, so now see, earlier positions are shown with black color and new position is shown with red color. So find out the distances of all the data points from new centroids again, and so on. That's what that is what is done here. In check. After finding out the distances again and again, we found out that okay, initially position was this one, then was this one, and now the position is this one double dash, right? Two, suppose two dash, two double dash, three, three dash, three double dash, four, four dash, four double dash. So now your centroids are these. Now again, find out the distances for all data points from these centroids. Right? So you need to repeat this step again and again till the positions of the centroid stop changing. And finally, we found out that position stops changing, and finally we found these four clusters. This is the first cluster, right? This one is the second cluster. This one is the third cluster, and finally this is the fourth cluster. We could have got 3 clusters also, but as we selected the value of k equal to 4, that's why we got 3 clusters, 4 clusters. Okay. So in the first cluster, all the data points have come. In the second, these are the points. In the third, these are the points. In fourth, these are the data points. This is what Kmeans algorithm is. So this is the basic idea behind Kmeans algorithm. To find out the value of k, we will be discussing about algorithm. Right. Now let me go and let me talk about mathematics in our DM. So same thing I'll be showing you by mathematical equations. Now till this point, anyone any doubt here? In Kmeans algorithm. Have you understood the basic idea behind Kmeans algorithm? What it does do? Whenever I say distance, try to remember it is Euclidean distance. I am talking about. Okay. And again, even if you are not aware about Euclidean distance, do not worry. Kmeans algorithm is going to take care of that. By default, Kmeans algorithm makes use of something called as Kmeans plus plus. This is a variant of Kmeans algorithm. Actually, what we do is we use while implementing, we use a method called as K-means, and inside K-means method we use this argument, right? So we'll be talking about implementation at that time. You will understand in Python. That's what we do actually. Okay. Anyone any doubt till this point? Have you understood the basic idea of K-means algorithm? Okay. Someone is asking, sir, what if we take k equal to 3? If there are 4 clusters, what now? See, Sharon, we are not at all aware about whether there are 3 clusters or 4 clusters or 5 clusters or 100 clusters. We are randomly taken the value, and that's why as we have taken 4 clusters for this, that's why we got four. As we have taken the value of k equal to 4, that's why we got 4 clusters. You can see you could have taken the value of k as even 10 also. It would have given you the cluster number of clusters as 10. But what's going to happen is in real time, what are we going to do? We are going to pass array of values. So we will pass 1, 2, 3, 4, 5, and so on till 10, 11, 100, 20, whatever it may be. According to the data, Kmeans algorithm is going to select the best value of these values as a value of k. That's why I told you you don't have to worry about the value of k. Are you getting my point, Sharon? It's not like that you can only select the value of k as 4 or 3. You could have. See, as I wanted to explain you the algorithm, that's why I have taken the value of k equal to 4. But in reality, what we actually do, we pass the array of values. And whatever is the best value, that best value will be decided by Kmeans algorithm for according to your data set. So no, we are not going to give a single value. It's not like that. It's not like that. We are going to pass an array. Suppose we will be making use of for loop for some k, in, you remember range function, right? So for some k in range 1 comma 20, then you will apply the logic. So whatever the best value out of this, that best value of k will be selected by Kmeans algorithm. And how Kmeans algorithm is going to decide about the best value of k? Elbow method, which we haven't discussed yet, which is not given in your syllabus. Okay, right. So try to understand. That's why I explain you why Kmeans algorithm and how. So why we have actually discussed that. How it was, we have discussed that. Now the point is, okay, I think only one person has doubt. Okay, no other people have any doubt. That's good, no problem. So now I will discuss about the mathematics involved. And let me tell you, okay, if you people are not interested in mathematics even, let me tell you, or if someone is aware about all these things, you tell me. No problem. Okay. If someone feels that okay, I already know this, let me know about that, and I will not repeat this. Okay. So let's see how Kmeans algorithm actually works. So at this point you can check the value of k needs to be specified first, and then the algorithm assigns the points to exactly one cluster. Okay, so value of k needs to be specified first. It means that elbow method first of all will be used before applying Kmeans algorithm. First of all, we will use elbow method, and to elbow method we will be passing number of values of k, and elbow method is going to give one value. And that one value we are going to pass it to Kmeans. So try to understand that. Okay. Now, whatever the logic we have discussed, whatever the steps which we have discussed about Kmeans algorithm, now see, the theory discussed above can be mathematically expressed as. So let's see, let C1, C2, Ck be the k clusters. Suppose there are k clusters, then we can write C1 union C2 union C3 and union so on Ck equal to 1 2 3 up to n. So what is this 1 2 3 up to n? This is your complete data. This complete data is divided into k clusters. Obviously, if you go and if you try to take the union of all the clusters, you are going to get a complete data set, right? That is, each data point has been assigned to a cluster. Each data point belongs to a cluster. And obviously, Ck intersection Ck dash is equal to phi. It means that there should not be any similarity between the clusters. If someone is present in the if some data set is present in the first cluster, obviously that data set will not be present in second cluster. So that's the thing it is actually talking about. Only just a mathematical representation. So yeah, why am I discussing this? You will understand that once you go and once you try to work with some projects. At that time, you will definitely understand why am I discussing this mathematical notations here. Okay? This is also important. Okay. And yeah, the people who generally go for research, definitely they will realize the importance of all these things once you start working on some projects. So obviously, this is that's why K-means algorithm is called as what? Non-overlapping. Why the word non-overlapping is used? Because of this one. Right? This means that clusters are non-overlapping. Right? The idea behind K-means clustering approach is that within cluster variation among the point should be minimum. Now there is a term which is used which is within cluster variation. So what happens is from the start itself I was talking about something called as elbow method, right? Now this elbow method makes use of something called as within cluster variation. So what happens is in elbow method what we do is we try to draw a graph, or elbow method works like this. There is a graph uh, on x-axis we have number of clusters, and on the y-axis we have something called as within cluster sum of square, or it is also called as inertia or within cluster sum of square or within cluster variation. Now as I told you that we are going to pass the value of k as 1 2 3 4 5 6 7 and so on. So those values of k, suppose 1 2 3 4 and so on till 20. So if there is only one cluster, so for one cluster you will get some within cluster sum of square value. What is that we will talk about. So in elbow method we make use of this particular thing. What is this? If I say there is only one cluster, so within cluster sum of square it means that addition of all the values in one cluster, addition of all the values or sum of all the values in one cluster. Obviously if it's one cluster that is going to be high. Then what if you divide this one into two clusters? It will be like this, and then go and then add. It will be something like this for two clusters. Within cluster sum of square will be like this. Then for three clusters, what it will be? It will be something like this. So what we do in elbow method is we try to draw a graph like this. Okay. So this particular term is actually from elbow method itself. But as we haven't discussed that, that's why I will wait for some time and then I will go and I will try to explain you what is this one. But yeah, something like this we do in elbow method, and depending on this one only, we decide the best value of it. How? Just we need to wait for some time. Let me just explain the working of Kmeans algorithm first mathematically. Let me explain this mathematics first. Okay. So that's why. Do not worry about this one right. For now, you just imagine this as sum of all the values in a cluster. That is nothing but within cluster variation. Okay. So how we represent it mathematically? So we represented that particular thing with this particular notation. Summation k equal to 1 to k. K is nothing but what? Number of clusters. So W of Ck is nothing but within cluster sum of square. WCSS. How to find out that? You need to wait for some time for that. Okay. So whatever the value of k for which we get minimum within cluster sum of square, that value of k will be decided as number of clusters, or k equal to uh, for example k equal to 5. So for k equal to 5 we are getting minimum within cluster variation. So that k value is going to be final. Okay. So once we decide that whatever the equation which you are able to see here, right? So what is this? This is nothing but within cluster variance only, right? But for the complete data set. Right. So see, generally the criteria is the Euclidean distance between two data points. I told you, right? Above formula says that we are calculating the distances between all the points in a cluster. So whenever we say distances, which distance? Euclidean distance between all the clusters. Then we are repeating it for all k clusters. That's why two summations. So as in the working of Kmeans algorithm, which we have seen just now with the help of diagram, right? What we do is we find out the distances of all the points from the centroids. As there are suppose four clusters, so we are going to repeat this way for all the four clusters or four centroids, and then we are dividing it by number of observations in the clusters. Actually, why we divide it with number of observations? Because that is the formula to find out within cluster sum of square. Okay, so to calculate the average, right? Don't worry about this particular equation right now. That will be taken care in algorithm. So actually, these mathematical equations are just showing you how Kmeans algorithm is actually working. As Kmeans algorithm makes use of within this elbow method, and elbow method makes use of something called as within cluster sum of square. That's why these equations are there, right? So ultimate for the complete data set, you will be able to find out that the equation which you are able to see here. So our final aim will be to minimize the within cluster sum of square. Okay, and that you will be able to see in case of elbow method. So try to understand to decide the value of k. We decide such a we try to select such a value of k for which within cluster sum of square is minimum. This is the only thing you need to remember for right now. Okay. So this is the mathematics which is shown here. You will be able to make some sense about this once we go and once we discuss about elbow method. Okay. Now that was the mathematics involved. These steps we already discussed, right? Randomly assign k clusters, calculate the distance of all the points from k clusters, from k centers. Once all the points are assigned to clusters, recompute the centroids and repeat the steps 2 and 3 until the locations of the centroids stop changing. Simple steps, 4 steps in case of Kmeans algorithm. Now, this Python code is written for what? This Python code is written just to explain you concept of Kmeans algorithm. This is not the implementation of Kmeans, okay? This is the code to explain you the concept of Kmeans algorithm with the help of diagram. Now, those people who are aware about the random methods or those people who are aware about matplotlib and seaborn, they will understand this. This is just for plotting the data. We generated the data, we colored that data in some color like blue color. Okay, this is not the implementation of actual Kmeans algorithm. Implementation is shown later on. So once you get this IPv file, don't take this one as the implementation. Those people who are interested in implementing, for them I am trying to talk about. Okay. So this is not the implementation. This is just to draw this kind of diagrams, which helped us to understand Kmeans better. Okay, and the explanation, whatever I explained you till now, that explanation is also given here. In these words, you can go later on and you can read it. Right? So just to plot this types of diagrams, I have used Python code. Okay, this is not the actual implementation of Kmeans algorithm. Where actual implementation is going to start, for that I have taken a data set. I will explain you that. Okay. So for actual implementation, let me show you a data set. Let me go and let me show you a data set. See, I will be making use of this small underscore customers data set. Okay, okay, people, I will take just 2 minutes. Okay, let me just explain you the data set. See, this is the data set I will be making use of. So to this data set, I will be applying K-means algorithm. In implementation, we will make use of this CSV file. You can check what is given in this CSV file. Customer ID, gender, right, male or female, age, income in $1,000, and spending score on the scale of 1 to 100. So 39, 81, 6, 77, and so. Now you can check what do we have. So we have near about 200 number of records. Now our target will be to apply Kmeans algorithm on this data set and then see in how many clusters you can divide this data. You can divide the data into, and then we will go and we will try to pass some test data set to this, and then we will check whether it gives us the result or not. So how many records we have right now here? So you can check. We have 200 number of records. So out of this 200, maybe 70% of records I will take it as training data, and remaining 30 I will take it as testing data, right? So, and from that we will try to create a model with the help of unsupervised learning approach, and that model is going to help us to divide this particular data into clusters. But in how many clusters? For that, you need to go and you need to decide about the value of k. And who is going to give us the value of k? So that method will be elbow method, and that is what is going to be our next point. So what I will do in the next session is, first of all, I will explain you elbow method, right, with this particular diagram, and then I will go and I will show you the implementation with the help of this cat CSV file, small underscore customers, right? So this is what I wanted to discuss right now. We will complete this KBS algorithm in the next session, right? So I will stop here and we will begin the next session. You can start changing your names and numbers. Okay, guys? So K means I will complete in the next session. So this is going to give us K1. Okay.